Hi guys, Northern Oklahoma College, Math 1513. It's College Algebra, Chapter 2, and I'm on Section 2. We're going to determine the domain of a function. Alright guys, let's think back to grade school. They made little tables and they used the words input and output. I forgot how to spell for a second. Input and output. And then you guys moved up to junior high, and they called this X and that Y. And then you guys moved up to college algebra, and now they call it X and f of X. But today, we're going to talk about the domain and range. Actually, today we're just talking about the domain. So when I ask for the domain, I'm asking what are all the possible x's that I can put into this particular function. Are there any x's that I can't use? What x's can I use? Let's look at this simple little function here, f of x equals x plus 1. All right, I want to know if there's any x's that I can't use, or can I use all possible x's? So I'm just going to make a little table here, and I'm just going to pick some x's, and I'm going to run them through the function and see what my y's are, what my f of x's are. So I run negative 2 through. Negative 2 plus 1 is negative 1. Negative 1 plus 1 is 0. 0 plus 1 is 1. 1 plus 1 is 2. 2 plus 1 is 3. And so on and so on. It doesn't appear that there's any x that I cannot use. So my answer is going to state that x can be anything. X can be all real numbers. So I'm going to say that, here's what I'm thinking. I'm thinking x can be any number. So I'm thinking in my head, x can be any number. And the way to say it mathematically is your domain is all real numbers. Same thing as saying x can be anything. You just say my domain is all real numbers. All real numbers will work. Okay, you guys know I love the Griffin Calculator, so here's my Griffin Calculator on my computer. And I have y equals x plus 1, I've plugged it in. So when I say f of x equals x plus 1, you just say y equals x plus 1 when you're putting in your calculator. And I come over here and look at my table, and I don't see that there's any x that I cannot use. So I say that I can use all real numbers. So that's a quick way to do it with your Griffin Calculator. All right, what about some special situations like f of x equals 5 over x? Now notice the x is in the bottom, so we've got to put our thinking cap on. Is there anything that x cannot be? Well, remember we're dividing. 5 divided by x. And there's one number we can never divide by, and that's 0. All right, we just don't know how to divide by 0. So since we don't know how, we say we can't define it, and we call that undefined. So I'm thinking if x equals 0, f of x is undefined. So that's what I'm thinking in my head. And here's what it looks like on the table. All right, here's x, here's f of x. I'm going to do negative 2, 1, 0, 1, and 2. I'm going to run those through the function. Negative 2 would give me negative 5 over 2. 1 would give me 5 over 1, or just 5. If I put 0 in, then I have 5 divided by 0, and my answer is actually undefined. If I put 1 in, I have 5 over 1 again, which is 5, and if I put 2 in, I have 5 over 2. Whoops, up here, this is supposed to be a negative 1, which would make that a negative 5, my bad. But you guys get the idea. The one x that I have to watch out for is 0. 0 will not work because in the denominator that will make my expression undefined. Now how do I write my answer? I'm thinking x, or domain, here's what I'm thinking. Domain is any number except 0. Okay, that's the right answer, but let's write the right answer using math. Now in the book they're using set notation, so let's start our set. And I'm saying my domain is all x's. I can use any x such that, that's kind of like saying except, I can use all x's except if x equals 0. All right? So I can use all x's such that x equals 0. And I actually said that backwards. X cannot be 0. So I need to draw a slash through my equals sign. There, now I've got it written correctly. So my solution set is all the x's such that x cannot equal 0. So anything will work, all real numbers except 0. Okay, and here's the same problem on a graphing calculator. Y equals 5 over x. Here's what it looks like. Notice that something weird is happening around the area where x equals 0. When x is all my negative numbers out here, they match up nicely to this curve. And when x is all my positive numbers, they match up nicely to this curve here. But when x is 0, something weird is happening right here. And here's what it looks like on the table. I run my x's through, and each x produces a value except 0. 0 did not produce a value because we can't divide by 0 because it's undefined. So another way to figure out your domain is to run it through a graphing calculator, pull up your table, and look at all your possible x's. And you can tell from this table right here that I can use any x in the world except the x 0 because that won't produce a y. All right, let's think about another special situation. What if f of x equals the square root of x? Well, what numbers do we know how to take the square roots of? Think about it. We can only take square roots of positive numbers. Okay, what's under the square root or what's under the radical needs to be a positive number. It can also be 0. We can take the square root of 0. So it can be any positive number and it can be 0. So domain is any positive number and 0. Okay, that's what I'm thinking to myself, and that answer is correct, but let's write it mathematically now. So our solution set is x, all x's, such that, remember that kind of means except for, so all x's such that, or as long as, x is greater than or equal to 0. So I'm saying the same thing. I'm saying x needs to be a positive number. That's why I put greater than, because numbers that are greater than 0 are positive. But I also said that x could equal 0. So x could be greater than 0. That means it can be positive. Or x could be equal to 0. So my domain is all the x's such that x is greater than or equal to 0, or as long as x is greater than or equal to 0. All right, let's see what this looks like on the table. If my x is 4, and I run it through the function, square root of 4 is 2. If my x is 1, square root of 1 is 1. If my x is 0, square root of 0 is 0. Now technically these guys produce 2 answers. But we're not so concerned with what the range is or what they're producing. We're more concerned with what x's we can use and actually produce a value. Now watch what happens when I put negative 1 in. So negative 1, I have the square root of negative 1. My calculator is going to say error, because we can't take the square root of a negative number. Now we know, we're smart enough to know that we call that I now. But the fact is that it doesn't produce a real answer. It produces a complex answer or an imaginary answer. So your calculator is going to say error anytime you try to take the square root of a negative number. So we know that right here is where my domain stops. I can use any numbers above that line, so 0 or greater. I can use any of those domain numbers, anything 0 or bigger. Okay, and back to the graphing calculator. Now notice that I've graphed y equals square root of x, but I've also graphed the negative part of it too. All right, because remember, anytime we take a square root, we get a positive answer and a negative answer. So my red line, my red curve, is the positive square root of x, and my green curve is the negative square root of x, just showing you both halves of the curve, the positive and negative aspects. But what I really want you to look at is the table over here, so that you can decide what your domain can be. Our domain, our x, can be 0 or 1 or 2 or 3 or 4 because they all produce answers. They produce a real number. They produce a real y. These negative numbers none of them produced a y. So they are not in our domain because they don't produce a real answer. So any number 0 or bigger will produce a real y, and so that's what our domain is. All right, another special situation, f of x equals 1 over square root of x. Let's put our thinking caps on and decide what x can be. Now it's a square root, and remember we can only take the square root of positive numbers. Okay, we remember that. So we know that x has to be positive. Now in the last example we said it could also be 0, but can it be 0 here? What if it is a 0? Let's just work that out real quick. 1 over square root of 0 equals 1 over 0 equals undefined. Okay, because we can't divide by 0. 0 cannot be on the bottom. So we can use positive numbers, but it cannot equal 0. This is how we say it in English. That's what we're thinking to ourselves. Now how do we write the answer in math? Well, we start our set of all x's such that, now what? X can be positive, okay, so no negative numbers. So x has to be positive. That means it's bigger than 0. Can it be equal to 0? No, it cannot. So we don't want to put that equal sign right there. So our solution set is all x's as long as x is greater than 0. All right, here's what your table would look like. If I put 4 in for x, it's 1 over square root of 4, which is 1 over 2. If I put 1 in for x, it's 1 over square root of 1, which works out being 1. If I put 0 in for x, there I'm undefined. And actually your calculator is going to say what? It's going to say error. Same thing for the negative numbers. 1 over the square root of a negative number is going to produce an error on your calculator. So that's what your table is going to look like. So the cutoff point for your domain is right here. That's where it stops producing real y's. Okay, here's what the graphing calculator looks like on my computer. Notice up here that I put in y equals 1 over positive square root of x, but also I put in the negative value too, 1 over negative square root of x, because square roots have positive and negative values. Now this graph is misleading. My red graph should go up like that, and my green graph should go down like this, but you can see that something weird is happening right here at x equals 0. Alright, and if we go to the table, we notice that at 1 or bigger, at values of 1 or bigger, we produce real y's. But at 0, we have an error. We don't produce anything, and neither do we produce anything for the negative numbers as well. So 0 and the negative numbers do not produce a real answer. So only the positive numbers produce a real answer for this graph. So that's how you can read it off the table if you pull it up on a graph. All right, here's a couple for you guys to work out now. F of x equals 6 over x minus 5. I want you to work this out and think about what x's you can use and what x cannot be. Now this is a fraction. Think about what the bottom, what the denominator cannot be equal to. All right, now remember, we can't divide by 0. That means that this cannot equal 0. Well, how do we figure that out? Well, we actually set it equal to 0 and figure out what it cannot be. So let's do that. All right, so we set x minus 5 equal to 0. We solve for x. We get x equals 5, but remember, actually x cannot be equal to 5. So if you want to think of it that way, x cannot be equal to 5. Now I accidentally circled that. That's not my answer. Remember the question was, what is the domain? So I need you guys to tell me what our solution set is. All right, and this is actually our answer. X such that x cannot equal 5. All right, another one for you guys to try. F of x equals the square root of 4 minus x. I want to know what the domain is. I want to know what are the x's I can use and what are the x's I can't use. So think about that. What x's can I use? All right, hopefully you guys are thinking 4 minus x, it has to be positive because we can't take the square root of a negative number, and 4 minus x is okay to equal 0. Now one last thing I want to show you is that we get down here to negative x is greater than or equal to negative 4. I need to divide off that negative. And when you divide off that negative, it flips your sign. So x is less than or equal to positive 4. So our domain is any x as long as x is less than or equal to 4.